Today we're going to continue looking at section 4.3, properties of logarithms. So we're going to continue to use the product, quotient, and power rule. We will now condense logarithmic expressions, and we're going to use something called the change of base property. All right, so in the last video, we were expanding, meaning that we started with one log and we were making it bigger into multiple logs. Condensing means that we are going to write the sum or difference of two or more logs into a single logarithmic expression. So we're going to use those properties that we learned about already. So once again, the product property, quotient property, and the power one. And we're going to use those to make it into from multiple logs into a single log. All right, so it is important to note that in order to write something down to a single log, the multiple logs that you see in the problem have to have the same base. If they don't have the same base, well, then you can't condense it down. But notice that in these examples right here, we do have the same base, which is why we are going to be able to condense. So in the first problem, we have log of 25 plus log of 4. Once again, remember, if I don't see that base, it is technically base 10, which is why I know that these two then have the same base. We don't have to write base 10, but that's what it is. So notice that the sign that we have, the sign that we have in between is addition. So remember, addition comes from the product rule, where we originally wanted to have then the terms be multiplied. So because they have the same base, I get to write that log once. And then because I know that addition was really based off of the product, I'm going to take the 25 and the 4, and we get to multiply those together. So it's going to become a single term there. Well, notice that 25 times 4 is going to multiply to get me 100. And once again, because this technically is a base of 10, we are going to be able to simplify. Because remember, we're thinking 10 to some power is going to give me 100. Well, 10 to the second power gives me 100. So this condensed down actually to the number 2. Notice that in the second problem, we have the same base. We have log of 7x plus 6 minus log of x. So notice that because I see a subtraction sign, that means that we want to be thinking about the quotient rule. So I'm going to write the word log once, and then I now want to deal with division. So remember, whatever expression was first, so 7x plus 6, that's going to be the numerator. Whatever expression comes after the subtraction sign is going to go in the denominator. Notice that 7x plus 6 is not going to be a factorable term, so there's nothing that I can simplify down as far as 7x plus 6 over x is going to be. And so because our expression contains variables, we're not going to be able to think about simplifying it down any further. So then this would be my answer. Okay, let's take a look at a couple more problems. Once again, we want to try to write it as a single logarithm. So notice that in this third problem, we have 2 times the natural log of x plus 1/3 times the natural log of x plus 5. Notice that in this example, I see that there are several numbers out in front of our logs. So if I'm thinking about then all the different properties, we want to think about the power property. I want to take that 2 and I want to make it an exponent to the x. I want to take this 1/3 and I want to make it an exponent to that x plus 5 term. So we will have the natural log of x squared plus the natural log of x plus 5 raised to the 1/3 power. Now I don't have any numbers in front of the logs, but I see that both of those logs, which have the same base, have an addition sign in between, which means I can continue to condense. Addition, we want to think about the product rule. So we'll have the natural log, and then we have x squared being multiplied by x plus 5 raised to the 1/3 power. Now, I'm actually fine with you leaving it like this. If you wanted to, because we technically have 1/3 for an exponent, if you want, you could write it as the natural log of x squared times the cubed root of x plus 5. Either one of these answers is acceptable, and I would take either one. All right, if we take a look at the next problem, we have 2 times the log of x minus 3 minus log of x. So I noticed that in the first term, I see a number that's out in front. So the first thing I'm going to do is I'm going to move that number back to being an exponent. So we'll have log of the quantity x minus 3 now squared minus log of x. Because we still have multiple logs and they share the same base, because I see a subtraction sign, I know that I want to be thinking about the quotient rule. So I want to do division. So I'm going to write the word log once, and now I know that I want division where the x minus 3 quantity squared has to be the numerator and the x has to be the denominator. Now, if you want, you could have, parentheses around that. If you don't, that's fine as well. But I'm not going to be able to simplify that x minus 3 quantity squared over x any further. So we have condensed it down as much as possible. All right, let's take a look at this one. We have 1/4 times log base b of x minus 2 times log base b of 5 minus 10 times log base b of y. Okay, once again, the first thing that I notice is that each of these terms contain a number out in front of the log. So that's always the first step. If I see that, I want to move them back to being exponents. So we really are going to have log base b of x to the 1/4 power minus log base b of 5 squared minus log base b of y to the 10th. All right. Now, if we notice, I actually see several subtraction signs. So when I see several subtraction signs, that means that subtraction means quotient. So I know that I want division. All of this is log base b, so I know that I am going to write it as log base b once. I want the only term that doesn't have a negative sign out in front, which is our very first term, to be the numerator. So we're going to have x to the 1/4 power. But then notice that we have 2 terms with subtraction signs, which means both of those terms are actually going to go in the denominator. So we're going to have 5 squared times y to the 10th power. Okay, because what you could do before you get to that, if you wanted to make it a little bit easier, maybe notice that I could take out the negative sign from both of those terms. So that's why then you'd have log base b of 5 squared, and then that would turn to plus log base b of y to the 10th. So notice that technically, because these two things were being added, that's why they're being multiplied down in the denominator. So you can ignore that step that I just created right here. Like, this step isn't necessary to show me, as long as you understand that however many subtraction signs you have tells you how many terms are then going to be multiplied in the denominator. Okay, the last thing that I'm going to do is, because I see that 5 is being squared, I can actually square that number. So once again, if you want, you can leave that as x to the 1/4 power, but then we would have 25 y to the 10th in the denominator. So this would be my answer. Or if you wanted to, it could be log base b. You could write that numerator as a radical instead. Either one of those answers are totally fine with me. So either one of these would be my final condensed. Notice how it's a single log answer. All right, go ahead and pause the video. See if you can write these as a single logarithm. Okay, so hopefully you noticed that there was a 2 out in front of the first log. So I moved that 2 up to being an exponent for the 6. I then squared the 6, Because I see an addition sign in between those logs, I could then multiply them. Notice how, because it's log base 12, I made sure that I wrote that base of 12 every time I was doing my step. And then because we have to think 12 to some power ends up getting me 144, hopefully we notice that 12 squared gets me 144, so 2 would be my final answer. In the second problem, notice that I moved all of those numbers out in front of the natural logs back to being exponents. If you notice that 9 to the 1/2 power is really the same thing as the square root of 9, which was something that I could simplify. So that's why it turned into the natural log of 3. Notice how we have 2 subtraction signs, which is why we're going to have 2 things in our denominator, because remember, subtraction, we think division. So only the 3 was in the numerator. The x to the 4th and the y cubed were both multiplied down in the denominator. But notice that we have the natural log outside written 1 time. And there are my condensed answers. All right, let's talk about the change of base property. So to calculate logarithms with bases other than 10 or e, because remember, in your calculator, you only see a log button, and so that's only base 10. You see a natural log button, so that's only base e. So what happens if I did want you to calculate something where maybe it was log base 3 or log base 8, okay? We could do that in our calculator, but we'd have to use this change of base property. So notice that it says log base b of m. If I wanted to type that into my calculator, it'd be log of m divided by log of b. So notice that because I don't have a base, that's technically base 10. So we're using the log button on our calculator, but we have to divide. So whatever the expression was goes in the numerator. Whatever the base of the original log problem was, that number goes in the denominator. The other way we could do this is that if I have log base b of m, we instead of using the log button, we could actually use the natural log button and we'll still get the same answer. But notice how once again the expression connected to the log is in the numerator. The base itself, that number, goes in the denominator. Okay, so once again we call these the common logarithms and the natural logarithms because it's base 10 for the common log and it's the base e, so natural log. All right, so we're going to use, the first one is the common log. So we're going to think with the log button, so base 10. We're going to do that to evaluate log base 7 of 2,506 in our calculator. So remember, we want to think of this as the b and we want to think of this as the m. So for using our definition that we just talked about, I write log of the 2,506 in the numerator, and then I write log of 7 in the denominator. And then we are going to type that into our calculator exactly how that is. But notice that when you type log and then you do the 2,506, make sure you close the parenthesis before you divide by the log of 7. Otherwise, you are not going to get an accurate answer. You're going to get a big decimal, so I'm going to ask that you round to 4 decimal places, please. So notice that we would get approximately 4.02, and then because it's 1996, I'm going to round up to 20. So it started as 19, I'm going to round it up to 20. So this is what it approximately is when we use the common log. Now we're going to do the exact same thing, but we're going to use the natural log. So once again, because 7 is represented as the base and 2,506 is represented then as the m, we're going to do the natural log of 2,506 divided by the natural log of 7. So once again, I'm going to have us round to 4 decimal places. And make sure that once you hit the natural log and you type in the 2,506, you close the parentheses before dividing by the natural log of 7. And once again, this is why we should be getting the same thing. And that's why it technically doesn't matter when we're doing the change of base formula if it's log base 10 or the natural log. Notice that we should get the same exact answer. Okay, so that's us using the product rule, quotient rule, power rule in order to condense. And we've now talked about the change of base property.